we're asked to calculate the divergence of the vector field f at the points -3, 3, and 0, -3. Let's first review the meaning of the divergence of a vector field. The divergence of a vector field measures the rate change inward or outward of a vector field, which is also called sync. For a velocity vector field, this would represent the rate of flow inward or outward from a given point. If the divergence is positive, the rate of change is outward, like a heated gas that is expanding. If the divergence is negative, the rate of change is inward, like a cooled gas that is being compressed. And if the divergence is 0, the change is not inward or outward, the vector field is incompressible. Another way to view the meaning of divergence is to think of a balloon at a particular location in the vector field. If we see small pieces of the balloon flying away in all directions, that's a sign of a positive divergence. If the balloon is being compressed, then the divergence is negative. If the balloon is being carried away without being stretched or squished, the divergence is 0. To determine the divergence of a vector field, we determine the dot product of the del operator and the given vector field, which if we have a two-dimensional vector field and p is the x component and q is the y component, the divergence of the vector field f is equal to the partial derivative of p with respect to x plus the partial derivative of q with respect to y. But for this example, let's go ahead and find the divergence using the dot product. So the divergence of the vector field f is equal to the del operator, which is the partial with respect to x, comma, the partial with respect to y, dotted with the vector field f, which has an x component of x cubed plus 3y, and a y component of x plus 2y squared. This is equal to the partial derivative of x cubed plus 3y with respect to x plus the partial derivative of x plus 2y squared with respect to y. For the first partial derivative, the derivative of 3x cubed with respect to x is 3x squared. The derivative of 3y with respect to x is 0. Then we have plus the partial derivative of x with respect to y is 0, plus the partial derivative of 2y squared with respect to y is 4y. The divergence of the vector field f is equal to 3x squared plus 4y. Now we'll determine the value of the divergence at the given points. For the first point, we have the divergence of the vector field f at the point -3, 3, which is equal to 3 times the square of -3 plus 4 times 3, which is equal to 9 times 3, that's 27, plus 12, which equals 39. If we look at the point -3, 3 in the vector field, which is located here, notice how the flow at this point does appear as if it would be outward, which is why the divergence is positive. And then we'll find the divergence at 0, -3, which is 3 times the square of 0 plus 4 times -3, which is equal to 0 plus -12, which is -12. Looking at the point 0, -3 in the vector field, which is located here, notice how it does appear as if the flow at this point is inward, which is why the divergence is negative. I hope you found this helpful.